Hello everyone, welcome to attend our class. Today we are going to study section 6.1, Methods and Forms of Welded Connections. As we know, welding is a process in which two pieces of metal are fused together by heat to form a joint. In section 6.1.1, we will study several welding methods commonly used in engineering, and in section 6.1.2, several types of welded connections will be introduced. The first welding method introduced in this class is the manual shielded metal arc welding, commonly called stick welding, which is designed primarily for manual application and is used both in the shop and in the field. In structural welding, this process is usually accompanied by the addition of filter metal from an electrode. During the welding process, an electric arc is formed between the end of an coated metal electrode and the steel components. As the electrode coating decomposes, it forms a gas shield to prevent absorption of impurities from the atmosphere. There are four types of commonly used electrodes in China, including E43, E50, E55, and E60. The letter E represents electrode, and the following number represents the minimum tensile strength of weld metal, whose unit is Newton per millimeter square. For example, E43 represents that the tensile strength of weld metal is 430 Newton per millimeter square. The designer must select the proper electrode according to the grade of steel. E43 electrode is used for Q235, E50 for Q345, E55 electrode for Q390, and E60 electrode for Q240. The second welding method is the submerged arc welding, which is primarily a shop welding process performed by either an automatic or a semi-automatic method. Its principle is similar to the manual shielded metal arc welding, but a bare metal electrode is used instead of a coated electrode. In the automatic process, an electrically controlled machine supplies the flux and metal electrode through separate nozzles as it moves along a track. The two types of welds that predominate in structural applications are the butt weld and fillet weld. According to the degree of fusion, butt welds are further classified as full penetration butt weld and partial penetration welds. Full penetration welds are those that achieve fusion of weld and base metal throughout the depth of the joint, which are made in a groove between adjacent ends, edges, or surface of two parts to be jointed in a butt, T, or corner joint. Partial penetration butt welds are made to connect partially thickness of base material by filleting the gap or groove between two parts. Partial penetration are used when load requirements do not require full penetration, or when welding must be done from one side of a joint only without the use of a backing bar. The butt welds may require extensive edge penetration as well as precise fabrication, and as a result, are more costly. Therefore, if possible, butt welds should be avoided because of their high cost compared with fillet welds. According to the geometric relations of welds, forces, and steel plates, butt welds can also be classified into straight butt weld, oblique butt weld, and T-butt weld. When the strength of the straight butt weld is lower than that of the weldment, in order to improve the bearing capacity of the connection, oblique butt weld is recommended. The cross-section of a typical fillet weld is a red triangular with equal or unequal legs. The distance from the theoretical face of the weld to the root is called the throat size. The leg size designates the size of the weld. The root is the vertex of the triangle, or the point at which the legs intersect. If the pieces to be jointed do not intersect at right angles, the welds are considered to be bevel fillet welds. The angle may be acute or obtuse, and the surface may be concave or convex. The fillet welds are also classified as oblique fillet weld, longitudinal fillet weld, and transverse fillet weld, according to the relative position between fillet weld and the applied force. That is all for this lesson. See you next time.